Welcome back. In our last session, we were discussing about network optimization problems, and in that network optimization problem, we discussed about one method of decision, that is gravitational method, and by using the coordinates on a graphical plane, we thought that where should we minimize the distribution cost as well as the distance, and on the basis of that with the help of a numerical example also we discussed this problem, and we saw that out of various market sources and the supply sources where to locate a particular warehouse. Now in that session also we started about discussion of a problem which is about a global supply chain environment, and we have taken some data to explain it on the global environment, but the same can be explained for a national level data also. Now in this case we have 2-3 major issues to be decided about the configuration of supply chain network. One is there are certain possible supply locations. So you have listed USA, Brazil, Denmark, Vietnam, UAE. These are possible supply locations, and in each of these locations you have an option either to have a low capacity plant or a high capacity plant. Now you need to decide three things: whether to have a plant at a particular location or not to have a plant, that is one. Second is whether to have a low capacity plant there or to have a high capacity plant there. So these are the three important issues: one, the location of plant, and second, the size of the plant, low or high. And then another issue is related to configuration of your supply chain model, in that there are certain demand locations: USA, Brazil, Denmark, UAE, Vietnam. Same 5 locations are the demand locations also, and in each of these demand location these supplied locations will fulfill the demand. So which combination of supply will go to the particular combination of destination. So we need to determine this combination also, that from here how many units will be transported to Denmark, from Brazil how many to Denmark, from Denmark how many to Brazil, or how many to USA, or how many to Vietnam. So depending upon the capacity which we have decided that we want to have a plant of 10 or we want to have a plant of 20, we will decide the capacity of we will decide this allocation of capacities to different demand destinations. So now with this type of problem, as I told you in the last session, we will build this Excel sheet, and I request all my participants to copy this data on your Excel spreadsheets almost in the similar fashion. Once you copy this data, then if you have some exposure of linear programming, if you know the linear programming, we require a similar kind of issue in this problem solving, where we will see there are certain decision variables. So there are 3 decision variables. One is whether to have a low capacity plant, whether to have a high capacity plant, or how many units to be supplied from a particular source to a particular destination. So these are 3 types of variables, these are 3 types of questions we want to determine, and for that purpose we call them decision variables. These 3 questions are 3 types of decision variables. So this portion of a spreadsheet from A12 to H18, this portion of spreadsheet is basically the allocation of those decision variables, and you can see this table, and here initially I have kept everything 0 0 0 0 here. all these values 0 0 are given by us. 0 0 means, to begin with, no quantity is supplied from a particular source to a particular destination. We are taking binary decision variables, as we discussed in the last class, for these plants. If a plant is open, 1 represents the open, 0 represents the plant is closed. So, right now initially there is no plant, there is no open plant, and all plants are closed, and therefore in the next issue we will see that how many units we are producing and how many units are going from a particular source to a particular destination. So, now once we have decided about the various decision variables and we have allocated particular cells for these decision variables, now moving further we will see that we have incorporated certain formulas in some of the cells, and the formula is like this. First we will talk of this formula that we are going to build in cell number B31, and this formula is our objective function. Now, objective function is actually the total cost of this exercise. Now, total cost of this exercise will be, if these plants are open, so the cost of these plants will be getting from the multiplication of respective cell with the respective cell of this column G4 to G8. If high capacity plant is open, the cost will be getting from multiplication of H14 to H18 with the respective multiplication of values from I4 to I8. Then the cost of moving and producing particular number of units at a particular source to a particular destination. So, that cost will be respective multiplication from cell number B14 to cell number F18 with cell number B4 to cell number F8, and that is what we are going to write in the objective function. So, you see, this is B14 to F18 will be multiplied by B4 to F8, that is the cost of transportation and production. G14 to G18 will be multiplied by G4 to G8, that is the cost of opening a low capacity facility. H14 to H18 will be multiplied by I4 to I8, that is the cost of opening a high capacity facility. Now, this becomes your objective function, and if you see, this is that B31, this place is B31. You can also do same thing in your spreadsheet and you put this formula in this B31. Please remember, always in the Excel, all the formula which you are going to build starts with this equal to sign. So, you as it is can write this formula here at this cell B31. So, this will give you the value of your objective function. Now, in our last session we discussed briefly about this constraints also. So, here we will discuss in slight detail about these constraints. Now, these constraints when we were developing the model in the last session, if you remember, there are two types of constraints. One is we want to fulfill 100% demand of each of my demand destinations. So, my demand destinations are USA, Brazil, Denmark, UAE, Vietnam. These are my demand destinations, and I want to fulfill these demands which are 12, 6, 14, 16, 7 respectively. So, I want to completely fulfill these demands, and another thing is that I cannot supply to each of these destinations more than their demands. So, if the demand of USA is 12, I cannot supply 13 there. I will try to fulfill the complete demand of this center. The second is the supply sources. These supply sources USA to Vietnam, right now you have all the values as 0, 0, 0, 0, 0. The reason I will just explain you, but we will not to have excess supply, excess capacity of these supply sources. A supply source, if it is of 10 units or 20 units, if it is a 10 unit supply source, it cannot supply 11 units from that. If it is a 20 unit supply source, it cannot supply 21 units from that. So, it can only supply 18, 19 or up to 20 in case of a 20 unit supply source. It can supply up to 8, 9, 10 units in case of a 10 unit supply source. So, what is the excess capacity available? Right now we are considering in the beginning of this problem that there is no excess capacity, and therefore the demand at all the destinations is unmet in the initial stage. Now, just to see the constraints, so these are the two constraints. One is the constraint coming because of supply and another because of demand. Now, when we are talking of supply constraints, so in the supply constraint you see that we have this cell B28, this B28 is this cell. So, this is the demand constraint, this is the demand constraint. Now, I want to fulfill this demand 12 here. Now, this demand is the result of whatever is available, whatever is the total demand of USA, that is 12, minus what all is supplied to USA from different sources. So, USA is getting from USA to USA, from Brazil to USA, from Denmark to USA, from UAE to USA, from Vietnam to USA. So, these are the units which USA is going to get. So, this is the sum of B14 to B18, B14 to B18. This sum, if I subtract this sum from B9, so that is my unmet demand. What I am trying to say that from B9, where I have written the demand of USA minus sum from USA is receiving from B14 to B18, that is what USA is receiving. So, B14 to F14, this becomes the value of unmet demand, that is this B28. So, B28 is equals to this B9, which is presently 12, and in the beginning all these are 0, 0, 0. So, the total is, this sum is 0. So, the value at B28 is coming to 12, and the same logic applies for Brazil, Denmark, UAE and Vietnam. So, I request all my participants of this course that for these values 6, 14, 16, 7, what you need to do thus, you just need to copy this formula B9 minus sum B14 to F14 from B28 to F28, and automatically all these values will appear. 6, 14, 16, 7, all these values will automatically appear. So, that is what we have written here, that this sum will come here, and you need to copy this B28 to F28, and this is B14 to F14, and then you will have these values. Now, coming to this excess capacity, the excess capacity that USA is supplying to USA, Brazil, Denmark, UAE and Vietnam, USA is supplying to all these different locations, and this formula, if I see, when you are supplying from USA to USA, Brazil, Denmark, UAE and Vietnam, in that case the total supply from USA is B14 to F14. This is the total supply from USA. This requires B14 to B18. This is the total receiving at USA. Now, this B14 to F14 which USA is receiving, supplying, and USA may make either value related to this cell or maybe value related to this cell. So, if it is yi here one or here one, that you need to multiply with the values of these two cells. So, what we have written here, that G14 multiplied by H4, G14 multiplied by H4, that G14 this multiplied by H4. So, this makes that you have a low capacity plant, plus if you multiply the value of this cell with this J4, then it means the high capacity plant. So, either you will be having a low capacity plant or a high capacity plant. So, this is what you are producing, and this sum of B14 to F14, this is what you are supplying. So, this formula, if you write in cell number B22, this will give you the value of excess capacity, and then you copy this formula from B22 to B26. Since initially you are having all 0 values, so therefore these excess capacities are coming to be 0. So, that is why you need not to write these values of zeros and 12, 6, 14, 16, 7. The formula will automatically give you these values. Formula will automatically give you these values, that how these zeros are appearing here and how these 12, 6, 14, 16, 7 are coming. And then once you have this, so and then you also write this objective function formula in this B31 cell. After that, now we go to start the solver activity. Now we go to start the solver activity. So, I hope all of you have done this building of formula and then copying those formula cells either to B22 to B26 or from B28 to F28. Then once you have developed this entire formula into this spreadsheet, then we invoke the solver. Solver we start, and in that case, now my target cell is this B31. So, here once you have this solver dialog box, so this B31 you write here, this is your target cell. As we discussed in the case of gravity model, here also you have option of maximum, minimum, etc. So, we want to minimize the cost, so put this symbol on minimization. Now, what you will do by changing the value, because this minimization is possible by changing the values of decision variables. So, your decision variables are from B14, this is B14, may not be very visible, it looks like 8 something, but it is B14 to H18, H18 this cell. So, from B14 to H18 you will change the values of these decision variables, and as a result of that, in this box you write the equations for the constraints, and these equations for constraints are, one is the values of B14 to H18, B14 to H18, all these decision variables are non-negative. All these decision variables are non-negative, they can be either 0 or any positive value. So, the first constraint represents that these are non-negative decision variables. You need to use this add button here for writing the constraints. So that add button you use for iterating the constraint. Then second is B22 to B26. B22 to B26, you can have any positive value of excess capacity. If this positive value of excess capacity is not there, if this constraint sign is reversed, the meaning of that can be you can supply more than available capacity at a particular supply source. So that is not possible, that is not in reality. So we need to put this constraint that from these source, from B22 to B26, you can have any positive value available, no negative value is possible. Or if a supply source is completely supplying whatever is available here, then it will be at best be 0. So there is no excess capacity, whatever is available you are supplying completely to the destinations. Then as we discussed in the beginning, that from B28 to F28, this horizontal line, this cell from B28 to F28, which are representing the unmet demand at different destinations, since we have assumed, we have modeled in such a fashion that you are going to fulfill the 100% demand of each of these destinations. So therefore, from B28 to F28, we are using this equality sign here. These cells are equal to 0. In some cases, if you feel that you can leave some of the unmet demand, if model suggests that way, that even if you are not going to fulfill the 100% demand of some of the destination, doesn't matter. In that case, you can have B28 to F28 greater than equal to 0. But in that case, there will be a big challenge, because we want to minimize the model. So what will happen? Minimization will lead maximum. There, if you put that there can be a positive value of B28 to F28. So do you think what is the potential risk with respect to our model? And it's a very interesting question, that you should understand the potential risk with respect to the model, because you are allowing positive values here. So positive value can be any positive value, it can be as high as 12, it can be as high as 16 for different locations. And when these unmet demands are there, so the physical significance is that you are not transporting, you are not producing anything here. And in that case, it will be very interesting that the total cost of this model will be 0. Total cost of this model will be 0 as soon as you change this sign of equality to left hand side greater than equal to right hand side. And I request all the participants, because it is now very easy for us to do that, you just, I am writing here equality sign, but you immediately try the greater than equal to sign here, and then this G14 to H18, these two columns, G14 to H18, these two columns are with binary sign, and the binary sign, that only 0 and 1, these two values are possible. So these are the 4 constraints we have put here, and after putting these 4 constraints, we put this symbol of, we click the solve button, and once you solve this button, and before I show you the next slide, you can see that because you have put greater than equal to sign here, and if you put solve click, then in that case you will see that the total cost of this model will come 0, and the excess capacities will remain as it is, and unmet demand will remain as it is, because we want to minimize the cost, and 0 is the lowest possible cost for any model. It is a dream type of situation. So nobody is going to produce anything, nobody is going to transport anything, and you are going to have zero cost of your model, and you know that is not the objective of this model. Therefore, we are building this type of constraint that left hand side is completely satisfied and there is no unmet demand. Yes, it is possible in some situation that you do not leave this right hand side totally open. You can make some kind of percentage that you need to fulfill at least 80% demand. You can try some of the variants of this question that I can say that you need to fulfill 80% demand of each of the destination. For different destinations, you can say that you need to full 80% demand of each of the destination, or it is also possible that you can have more number of constraints and you may say that for USA market and Denmark market you have to fulfill 100% demand. For Vietnam market you should fulfill 80% of the demand or even more than, it is very good. For Brazil market again 80%, UAE market 75%. So for different markets you may set different criteria and all those criteria need to be built into these constraints. So this is a simple generic model, but more customized, more specific model can be built by writing the constraints for that in this constraint dialog box. Now going further, once you have started your solver and the calculations are going on, it will take some fraction of seconds to complete the calculation, and then this type of model will emerge. This is the solution of the model, where you see, let us first see where are we going to open the plant. So where we are not going to open any low capacity plant. For all low capacity plants it is 0 0 0 0 0 here. So there is no low capacity plant. You have three ones in high capacity plant, one for Brazil, one for UAE and another for Vietnam. So you are going to have three high capacity plants in these three locations. You have some values in these two cells, one for USA and another for Denmark. So these are 10 to the power minus 13. These are because of internal calculation errors in Excel. So that's how these are 10 to the power minus 13, both these values. So these are almost, you can say, equivalent to 0, non-significant. So we consider them also as 0. So in fact you will have three high capacity plants, one at Brazil, one at UAE, one at Vietnam. So that is about the size and location of your plants. Now the second question we want to answer, that from which facility how much you will ship to a particular location. Now you see, in USA you are not going to have any type of plant, neither small nor bigger. So you are not going to ship any unit from USA. So USA to all other destinations it is 0 0 0 0 0. You are going to have a bigger plant of 20 units at Brazil. So from Brazil you are shipping 12 units to USA. You keep 6 units of that in Brazil itself, because the demand of the Brazil is 6. So Brazil will fulfill all its demand from the local capacity. So 6 will come to Brazil and 2 will go to Denmark. So 12 plus 6, 18 plus 2, 20. So the Brazil capacity is now exhausted, and Brazil will not supply anything to UAE and Vietnam markets. Now again in Denmark there is no plant. So you are not going to supply anything from Denmark to any of the destination. You have one bigger plant in UAE. Now the demand of UAE is, you see, interestingly, only 8 units of its own plant will be consumed in UAE, and remaining units, out of that 12 will go to UAE, 12 will go to Denmark, and that is how 12 plus 8, the UAE capacity will be exhausted. And in case of Vietnam, again you are going to have a bigger plant. Vietnam's own requirement is 7 units. So out of 20, 7 will be consumed at Vietnam itself and remaining 8 will go to UAE, and 7 plus 8 makes 15. So Vietnam will be left with 5 units of excess capacity that you are seeing in the cell number B26, and in all other cells USA and Denmark, these are 10 to the power minus 12, so almost equivalent to 0, and for Brazil and UAE also you have 0 values. So in fact you can say USA, Brazil, Denmark and UAE have no excess capacity, and you have a excess capacity of 5 units at Vietnam. And then you see the unmet demand. In case of this B28, here you are showing some kind of 10 to the power minus 12 type of value, where it again means non-significant, it is 0, and for all other Brazil, Denmark, UAE and Vietnam, these are 0 unmet demands. The meaning is that with this model now, you see you have 3 plants, your 5 units are excess, and the cost is coming 23,470 rupees. So this model is a very perfect type of model where you decided where to locate your manufacturing facility, what will be the size of that manufacturing facility, and how are you going to configure your supply chain network, which facility will supply to which market. And the customization of this model, as we discussed, can also be done depending upon our requirement, that if we want to have in this particular case you are making 5 units additional at Vietnam because you wanted to fulfill 100% demand of all these destinations. Now you see, if it is possible that I do not fulfill 100% demand of some of the location, so maybe at Vietnam I can work with a smaller facility, and in that case I may remain with some of the unmet demand in some of the location, and that may reduce my cost of supply chain. But it depends upon my supply chain strategy whether I want to completely fulfill the demand or I can bear with slightly lower level of service. So I think we can try various versions, some of the versions which I can suggest you, that you should go with different type of constraint combinations. Here in this case, one constraint combination, you note that you can have any kind of unmet demand, you have any kind of unmet demand available. In this case there was no unmet demand left, but another constraint can be you have some unmet demand left. In that case you will change this sign of equality into greater than equal to, and just see the results. The result will be 0 cost here. This is case number 1. Now case number 2, you try that the demand at Vietnam need not to be fulfilled 100%. You can have 80% demand of Vietnam to be fulfilled, and in the same case UAE only 80% of the demand need to be fulfilled. So you see that you need to apply 2 additional constraints from B28 to F28, it is not. Then in case of B28 to D28, it will be equal to 0, and you need to write 2 additional constraints. One for UAE, that is for E28, and another for F28. So you see that what will be those 2 constraints. For UAE, the constraints will be that this is E28 should be, in this case it is equal to 0, but in this case it should be greater than or equal to, we want 80% of the demand to be fulfilled, 80% of E9. Similarly, if I want 70% of the Vietnam's demand should be fulfilled, so it means F28 should be greater than equal to 0.75 of F9. So you need to customize. I am giving you a very generic version, but you need to customize this as per the situation, and then this solver activity will help you in getting the results very quickly, and you can try different type of conditions depending upon the supply chain strategy, and then get the results. Whichever result gives you the minimum total cost, that is what we want to have in our supply chain network. Thank you very much.